High above the clouds, carved into the raw stone of the Swiss Alps, stands a colossal wall of concrete that has quietly shaped lives for generations. For nearly 100 years, it has restrained an inland sea of mountain water, transforming gravity into power and isolation into opportunity. Born during an age when ambition outweighed caution, this dam became a monument to human determination, daring to challenge one of the harshest landscapes on Earth. But time is relentless. Wind, ice, pressure, and decades of silent strain have slowly pushed this aging giant toward its limits. What once symbolized mastery over nature now demands intervention. And so, in one of the most remote and unforgiving locations on the planet, Switzerland has launched a replacement effort unlike anything attempted before, an engineering gamble where failure is not an option. This is not a simple repair job. It is a full-scale reinvention, a project designed not just to match the past, but to exceed it. Advanced engineering, sustainable energy ambitions, and environmental responsibility all collide here, thousands of meters above sea level. Brutal weather, thin air, and fragile alpine ecosystems turn every decision into a high-stakes calculation. Replacing a dam in a place like this is as much about restraint as it is about strength. At the heart of this story lies Lake Grimsel, in the Bernese Oberland, where the Spitalum Dam plays a crucial role in Switzerland's renewable energy network. Built between the mid-1920s and early 1930s, it predates America's Hoover Dam and was revolutionary for its time. Its curved arch-gravity design allowed it to withstand immense water pressure with remarkable efficiency. Rising over 100 meters and stretching across the mountain basin, it was constructed almost entirely by hand, powered by the labor of hundreds of workers battling altitude, cold, and isolation. For decades, the dam delivered reliable hydroelectric power, helping stabilize the nation's energy supply. But age eventually revealed its weaknesses. In the 1960s, engineers discovered a serious structural issue, not a surface flaw, but a deep vertical separation within the concrete itself. A massive section of the dam had begun to slowly pull away from the rest of the structure. Year by year, the gap widened. On its own, Switzerland's seismic activity is usually mild. Most tremors barely register. But history has shown that stronger earthquakes are possible. The nightmare scenario is not today, but decades from now, when that internal split has grown too large to ignore. A major quake could send part of the dam collapsing into the lake, displacing enormous volumes of water and unleashing destructive surge down the valley below. Engineers explored every option. Patching the cracks seemed logical, but investigations revealed that such repairs could trigger chemical reactions inside the concrete, weakening the structure over time. Dismantling the dam entirely was equally unrealistic. There was nowhere to divert the water, and shutting down the reservoir would cripple hydroelectric production. In the end, only one viable solution remained: build a new dam directly in front of the old one. The plan is as bold as it sounds. A modern structure will rise just meters away, and once complete, the space between the two will be flooded. The original dam will remain, preserved beneath the water, a silent relic of early 20th century engineering. The replacement project officially began in 2019. While its budget of roughly $140 million may seem modest for a megaproject, the difficulty lies not in cost, but in execution. The first challenge was creating space for the new structure. Solid alpine rock had to be removed using carefully controlled blasting, all while standing directly in front of a dam holding back a massive lake. One mistake could compromise the entire system. The new dam is a double curvature arch-gravity design, rising high and built to modern safety standards. It will consume over 200,000 cubic meters of concrete and have been engineered to allow future height increases, expanding water storage if needed. Throughout construction, Lake Grimsel continues operating as a reservoir, ensuring uninterrupted energy production, a delicate balance of progress and continuity. Perhaps the greatest pressure on the engineers is this: every drill, every blast, every pour of concrete happens with a fully loaded lake just meters away. The old wall must remain stable at all times. There is no margin for error. Even supplying materials is a challenge. To meet the enormous concrete demand, an on-site production plant was built, using granite extracted from nearby construction work. This closed-loop approach reduces transport needs and environmental impact, a crucial consideration in such a pristine setting. When the new dam becomes operational, the old structure will gradually disappear beneath the reservoir, preserved rather than destroyed. Construction is expected to take 6 years, with completion targeted for the mid-2020s. Working at over 2,000 meters above sea level brings its own trials. Heavy snowfall, freezing temperatures, and violent storms shorten the building season to just a few months each year. Equipment and supplies must be flown in by helicopter or carried across temporary roads and cable systems. Every task must be meticulously scheduled, every delay costly. At the same time, the surrounding Alpine ecosystem demand protection. Strict environmental safeguards govern waste handling, habitat restoration, and water quality monitoring. Engineers must maintain the reservoir's operation while ensuring the natural balance of the region remains intact. And as the final concrete pours harden and the scaffolding slowly disappears, the story of this dam enters a new chapter. What began as a response to a structural flaw has evolved into a global case study in how nations can responsibly modernize critical infrastructure without sacrificing history, safety, or the environment. The lessons from Grimsel extend far beyond Switzerland. Across the world, thousands of dams are approaching the end of their design lifespans. Many were built with outdated materials, limited seismic knowledge, and engineering assumptions that no longer hold true. The approach taken here proves that replacement does not have to mean removal, and that innovation can coexist with preservation. This project also signals a shift in how energy security is viewed. Hydropower is no longer just about producing electricity. It is about flexibility, storage, and resilience in an era of climate uncertainty. By increasing capacity and reliability, the new dam strengthens Switzerland's ability to balance renewable energy sources and respond to future demand. Perhaps most striking is the human element. Engineers, construction crews, pilots, and planners operate daily in an environment that offers no forgiveness of mistakes. Every successful phase reflects not only advanced technology, but trust, coordination, and discipline on an extraordinary scale. When the lake finally rises and the old dam slips beneath the surface, it won't be forgotten. It will remain there, embedded in history, supporting a new structure that carries its legacy forward. A reminder that even the strongest creations are temporary, but thoughtful engineering can give them new life. In a place where mountains seem eternal, this project quietly challenges that illusion. It shows that endurance is not about resisting change, but about adapting to it. And high in the Swiss Alps, behind a wall of modern concrete, that lesson now holds back millions of cubic meters of water, waiting for the next century to begin. Long after the machines shut down and the last workers leave the site, the impact of this project will continue to ripple outward. Energy produced here will power cities far below the mountains, silently fueling homes, industries, and everyday life. Most people will never see the dam, never feel the cold winds or hear the echo of drills against stone, yet their lives will be shaped by the choices made in this remote Alpine basin. This is the paradox of great infrastructure. When it works, it fades into the background. No headlines, no applause, just quiet reliability. But behind that silence lies decades of planning, risk, and human effort pushed to its limits. The new Grimsel Dam stands as proof that the future of engineering is not just about building bigger, but building wiser. It reflects a mindset that values long-term safety over short-term fixes and foresight over convenience. In an age where shortcuts often dominate decision-making, this project chose patience, precision, and responsibility. As climate patterns shift and water becomes an increasingly strategic resource, structures like this will matter more than ever. They will decide how societies adapt, how energy is stored, and how communities are protected from both scarcity and disaster. High in the Alps, surrounded by ice, rock, and sky, this dam tells a quiet but powerful story. A story of humans confronting their own creations, acknowledging their limits, and daring to rebuild before catastrophe forces their hand. Not because failure was inevitable, but because prevention is the greatest form of progress. And sometimes, the most remarkable achievements are the ones that ensure nothing dramatic ever happens at all. What is unfolding at Grimsel is more than a construction project. It is a statement about how modern societies confront aging infrastructure. As dams around the world face similar challenges, the methods tested here offer a roadmap for the future. Safer designs, smarter materials, and environmentally conscious construction may define the next generation of hydroelectric power. In the shadow of the Alps, where ice, stone, and water meet, Switzerland is proving that progress does not require erasing the past. Instead, it can build upon it, carefully, deliberately, and with respect. What do you think about this daring mega project? Share your thoughts in the comments. Thanks for watching, and we'll see you in the next video.